Hi everyone. In this second video clip, we will discuss the mechanical testing of fuel injectors. Today, the research team from DTD Auto would like to provide a detailed and precise explanation of the process, carried out in a slower, step-by-step manner, to help users understand how to perform this test correctly. Essentially, this testing method has been developed and quantified based on programmed algorithms and careful calibration, resulting in the highly accurate outcomes you will see in this demonstration. The method presented here is extremely precise, ensuring full reliability and confidence for users. As we all know, determining whether a fuel injector has a mechanical fault or not is quite difficult. Without proper diagnostic tools or equipment, it is practically impossible to test the mechanical condition of an injector. For example, issues such as sluggish or heavy mechanical movement, insufficient electromagnetic induction due to inadequate copper winding turns, poor quality injector needles, or a return spring with incorrect stiffness. All these mechanical defects can lead to fuel delivery problems. Since the injector operates under high-frequency control and within precise millisecond intervals, manual or improvised testing methods cannot deliver reliable results. Therefore, this solution has been developed after extensive research by our team to allow accurate mechanical inspection of fuel injectors. With this method, users can easily distinguish between OEM standard injectors and low-quality, counterfeit, or imitation injectors. Poor injectors will show clear deviations in testing results, while genuine OEM injectors will display stable and accurate performance. In this demonstration, we will test two injectors. One low-quality injector that causes engine power loss or unstable idling. One OEM standard injector recently purchased from Honda for comparison. We will use the MOTOSCAN tab diagnostic tool to perform this test and demonstrate the difference in fuel flow characteristics and mechanical behavior between the two injectors. When the OEM injector is installed, the engine maintains consistent fuel flow, optimal magnetic response, and stable performance, ensuring rated power output without misfire or hesitation. Next, we will proceed with the injector mechanical test using MOTOSCAN tab and the accompanying software. Please follow the on-screen instructions in the MOTOSCAN tab software. Select the function Advanced Diagnosis. Choose Actuator. Then select Injector Mechanical Advanced option. Note: do not confuse the Fast Test mode with the Advanced Test mode. The Fast Test only performs an interpolation-based estimation, whereas the Advanced Test uses a fully quantitative measurement method that provides high-precision results. Even slight mechanical abnormalities in the injector will be detected. This functionality has been meticulously developed and optimized in MOTOSCAN tab version 3.2. offering precision unmatched by any other diagnostic equipment currently available on the market. Upon selection, the system will display a message. The test assembly uses a custom CNC machined mica and glass fixture designed for user convenience. We utilize hand-tightened knobs instead of conventional screwdrivers to ensure ease of adjustment and avoid over-tightening. Every component of the measuring fixture has been precisely calculated, especially the fuel level gauge. Inside the measurement tube, the gauge markings are defined as follows. Green zone, injector performance within OEM specification. Above green, red zone, excessive fuel delivery, overconsumption. Below green zone, restricted fuel flow, weak power, engine hesitation. In this demonstration, we will test a 125cc OEM fuel injector. Purchased from Honda, as a reference example. Step 1. Preparation. Remove the fuel injector and its electrical connector from the vehicle. Do not disconnect the fuel delivery hose. Connect the injector to the MTB08 inbox test fixture. Plug the MTB08 INJ cable into the injector connector, as shown in the provided wiring diagram. Short-circuit the mass, ground, terminal of the fuel pump to keep it running continuously. Choose a convenient and stable connection point. Turn the ignition switch on. Ensure that the battery is in good condition. The voltage is greater than 12.6 volts. The fuel pressure meets standard specifications. Step 2. Power and pressure requirements. This testing method uses the actual battery voltage and in-vehicle fuel pressure. Therefore, both must meet precise technical standards to ensure valid results. Battery voltage. Step 3. Selection of parameters in MOTOSCAN tab. Before starting the test, the user must enter the actual measured values. Fuel pressure, as measured on the vehicle. Battery voltage. Injector type. Example. If the fuel pressure is measured at 3 kg per square centimeter and the battery voltage is 12.6 V, input these exact values into the software. Incorrect data entry will lead to inaccurate calculations. Select Start. Step 4. Test duration and operation. Once initiated, the software will indicate test progress as a percentage. The total test duration ranges from 5 to 6 minutes, depending on the injector type. MOTOSCAN tab controls the test automatically via Bluetooth communication with the MTB08 inbox, so no direct connection to the vehicle ECU is required. During the process, the injector operates in real time, under controlled pulse conditions. You may observe the injector spray pattern through the glass tube. To evaluate the spray quality, ensure your line of sight is directly aligned with the injector nozzle, not from the side. A proper injector produces a fine mist-like spray pattern, a uniform cone angle, not distorted or streaked, and consistent atomization throughout the pulse duration. However, spray pattern quality alone does not guarantee full injector health. Fuel delivery quantity must also meet the program standard to achieve proper air-fuel mixture formation. During the test, the MOTOSCAN tab system continuously monitors performance and displays. Injector mechanical test in progress. Please wait. The virtual assistant periodically announces progress. This allows the technician to perform other tasks during testing, as the system operates autonomously until completion. Instead, it uses a proprietary control algorithm that simulates real driving conditions and pulse width modulation at microsecond precision. This represents a technological breakthrough exclusive to DTD Auto's research. When the process reaches 100%, the system announces notification. Injector mechanical test completed. Compare the actual fuel level in the measurement tube with the reference image on the screen. The reference chart on screen corresponds to colored zones on the measurement tube. Green zone, fuel delivery within OEM specification. Injector good. Red zone, above green, excessive fuel flow. Injector worn or leaking, causes fuel overconsumption. Below green zone, insufficient fuel delivery. Injector clogged, dirty, or mechanically faulty, causes engine hesitation and power loss. After the test, remove the measurement tube and observe the actual fuel level. If it aligns with the green marking, the injector meets OEM standards. To confirm whether a specific injector is the root cause of poor engine performance, technicians may repeat the test using a suspect injector that previously caused engine hesitation. Follow the same installation and connection steps as before. If the injector passes electrical checks, i.e. no error code 12, which corresponds to an electrical circuit fault, but fails this mechanical test, it indicates an internal mechanical problem undetectable by standard diagnostic tools. Currently, no other diagnostic equipment on the market, except MOTOSCAN tab, can perform this mechanical integrity test of fuel injectors. This feature represents a pioneering advancement by DTD Auto's engineering team, achieved through rigorous scientific research rather than trial and error methods. During diagnostic procedures, many technicians may mistake electrical faults for mechanical faults within the fuel injector. It is important to distinguish the two. Electrical faults, code 12. These occur when the injector's control circuit is open, shorted, or has coil resistance outside specification. The ECU detects these errors and displays corresponding fault codes. Mechanical faults. These are not detected by the ECU. They include issues such as sticky or slow-moving injector needle, weak or fatigued return spring, worn internal components, reduced magnetic induction due to low-quality coil or material defects. Mechanical faults can only be detected using specialized tools, such as the MOTOSCAN tab, that simulate injector operation under real electrical and hydraulic conditions. Even if no error code appears on the ECU, the injector may still be mechanically defective, causing unstable idling, misfire, or fuel consumption imbalance. In this section, the team proceeds to test a suspect injector that causes engine hesitation. The testing process is identical. 1. Install the suspect injector into the MTB08 fixture. 2. Connect electrical and fuel lines according to the standard setup. Three. Input the actual battery voltage and fuel pressure into the MOTOSCAN tab software. 4. Select the correct injector type, 125 cc. 5. Click Start to begin the mechanical test. During testing, although the spray pattern may still appear normal, with acceptable atomization and cone angle, this does not guarantee proper fuel flow rate. Only the software's internal algorithmic fuel quantity analysis can determine whether the injector meets required delivery parameters. This algorithm has been developed and validated by DTD Auto through extensive laboratory calibration and testing over several months, ensuring accurate, repeatable results. The verification process has been completed. We will now proceed to review the results. This is a faulty injector. Low fuel volume will cause noticeable power loss and hesitation during acceleration, even though no AQ fault codes appear. To confirm findings, reinstall the fuel injector onto the motorcycle. Check the engine performance by starting the engine and twisting the throttle. Conclusion: the motorcycle is experiencing a severe poor acceleration issue. Technicians can use this elimination method to quickly determine whether issues originate from the injector, the sensors, or the ECU. This ensures accurate troubleshooting without unnecessary part replacement. Thank you for following this demonstration video and documentation. Please share your feedback and comments to help us improve future products.